Hello, everyone. Welcome. Thank you all for joining. How are you? Um, uh, in today's session, we're going to be speaking about batteries. We'll be waiting a couple minutes while people finish joining. So everyone is here when we start. You can go grab a glass of water, a cup of coffee, whatever you like, and we'll start in just a couple minutes. Okay, I think we're gonna start now. Let me put this in full screen mode. Okay, so thank you again for joining, everyone. Today's topic is going to be accelerating battery energy storage system design with industry-proven layouts. I will be your speaker today. I'm Gorka. I'm the product owner for at RatedPower. I work with the product team and all the developers to bring you all the features related to battery storage. You have my email there. Feel free to reach out if you have any questions. I will be doing a Q&A at the end of the session. You can write your questions any time. And yeah, if you still have, feel free to reach out to me. So the agenda for today is this one. We'll see what is the feature about, how does it work, which are its benefits. We'll do a short poll, and then we'll do a quick, but not that quick, in-depth demo of the new feature. So what is the feature about? Right. The objective or the aim of this feature was to bring basically to the user the control over the layout. So this way, we will allow the users to be able to replicate industry-proven or real-world battery layouts in a few clicks. Have your layout replicated with the manufacturer guidelines, with your local regulation setbacks, everything basically you need to have a reliable layout in a few clicks to accelerate all your process or your design or pre-design preliminary design, let's say, phase. So you can have all the documents, all the layouts ready to present to the project. With this new feature. So we will increase the flexibility and the positioning of the elements, give control over the setbacks, and give you different options to change the layout distribution, orientation, and so on. So how does it work? Well, I'll go a bit more into depth in the demo about how we generate the layout, but basically with this new feature, the idea is that users can choose the distribution of the elements of the layout from different options. These options were defined based on the most common industry-proven layouts available from the top tier manufacturers. You also be able to define the setbacks between the different elements, and not only between the different elements of a block, but also between the blocks and so on. So you basically be able to comply with everything that manufacturers and local regulation sets. And also super handy, you'll be able to save all of these configurations into a template, so you can use it in all of your projects without needing to input everything again manually, and basically streamline this design process, and also reduce all the revision time that goes into checking on the distances, seeing if this is okay, if I have to increase the setback here. All this will be automatically done once you've done or you've done it the first time, and save it for later. Which are its benefits? Well, I think you can already grasp a bit from what I say, but benefits, it's very easy now to generate um, a layout that's usable and that replicates your manufacturer guidelines. No more manual and container and PS placement. You can generate the layout that you need for your project. It's compliant. As I mentioned, you can define the setbacks that you need, save them as a template, and then load them in each of the designs. So you reduce all this revision time, risk of maybe making an error in some input, and so on. And finally, it's reliable, because we generate with all of this information. We generate the layout. Uh, we generate also single line diagrams. We generate a lot of the design reports and so on, that you can then use in your projects. So this was the context of the feature. I think the most interesting part. First, we want to do a quick poll. So if I can get out of the presentation screen for a second, I think you should be seeing a poll right now. You can vote for which manufacturer layout you would ask to replicate right now in the live demo. So you can choose whatever option you want from the ones you have available. We can generate, we can replicate Teslas, we can replicate Sangros, we can replicate maybe CATL, whichever one you want. Okay, I see a lot of voting Sangro and CATL. Wow, okay. I was expecting another distribution for the votes, but I like it. I think top one is Sangro, top two is CATL, and last is Tesla. All right. Yeah, so Sangro was the winner. Let's try to replicate one of their most common layouts. So let me share the other screen. Okay, I think you can already see the software. Okay, so this is RatedPower. Those of you that are familiar with the software will remember this screen. We are right now in the BESS tab to configure everything related to batteries. This is the demo plant that I have here. It's a hybrid plant with trackers for PV, switching and braking station, substation, another switching and braking station here, and our batteries here on top of an existing substation. I assume this is so. First thing if we go into the inputs, first thing that you will notice is, if you are familiar with the software, it's a change here in this part for the supply cycle duration. So how we work at RatedPower, how we generate the designs, it's all parametric. The user is the one defining what container he wants, what the distances, the capacity, and so on is going to be. So we first define the, let's say, the minimum block, which means the minimum block is the containers connected to the same PCS. So in this case, we will have two containers connected to one single PCS. This will be our minimum block. What we do is take that block and replicate it through the whole battery area until we reach the specific capacity that the user defines, or maximum capacity if they want to fill the whole area. This is important because for this new feature, the distribution options available won't be for every single configuration, but just for when we have 1, 2, and 4 containers connected to the same PCS. This is not always going to be like that. Okay, the idea of the feature is to keep improving it and to keep adding more and more topologies or more and more configurations for the uneven and other number of containers per PCS. So in this case, we have two containers connected to the same PCS. We can go here and choose from the supply hours. The supply hours are really dependent on the number of containers that are connected to the same PCS, right? Because we're changing the capacity power ratio. So in this case, we have two containers. We can change it to 1, and you'll see the number of hours changes and the number of containers changes. Okay, let's stick to two containers per PCS for now. If we go into the layout section, new changes come in here also. This one, the most noticeable, the block distribution. So in here you can choose the different configurations, right? For two containers, as we see, connected to the same PCS. So depending on which one you choose, will generate one kind of distribution or the other. And in here you can define the distances between the different elements of the layout. In this case, the two containers and the PCS. So as I mentioned before, we were going to replicate the Sangro layout. So we're going to, okay, I think I have the dimensions correct right now. In here, you can define the dimensions of the container and the PCS. If we take, for example, typical, well, how's it called? The Power Titan, for example, Sangro's Power Titan, well, not the Power Titan. We're going to go for the ST 5015, which has this. It's the typical 20-foot container with the typical 20-foot container also for the PCS and the MV system, MV kit. So we're going to choose this one to put the containers vertical and the PCS. And then we have this other option here for the PCS orientation, always with respect to the battery containers. So in this case, we have the containers vertical, right? And we have this PCS parallel to those vertical containers. Although in the image you see both horizontal, as this is always with respect to the container. If we choose here vertical, this will be also vertical. If we choose here perpendicular, we'll see the containers vertical, PCS horizontal. Okay, this may be a bit confusing. First time you use it, you'll get the hang of it super quickly. And next thing important is the block alignment. Okay, this is also new. Here you can choose the orientation of the different blocks. You see how right now we have the same orientation for each one of the blocks. If I choose mirrored, you'll see that the PCSs, instead of being pointing towards the same direction, all of them they will be like confronting one each other. So if I can maybe, I think I do have an example here, right? Yes. So here you can see how with this new orientation, all the blocks are looking at each other. If I will choose back to back, which I also have an example already here, already done, you can see how we have essentially the same as mirrored, but just the other way around. And last but not least, you can define the different setbacks between the different blocks. So when we say block, we define the block as the individual components of the battery system. So this is the containers that are connected to a single PCS. In this case, we have two containers connected to one PCS. If we put them in the layout like this, the block will be the rectangle that contains all these elements, like this imaginary rectangle, right? So in this case, we see, I think you can barely see it, but you can see the dashed line here. This represents the edges of the block. So when we define the distances between the blocks, is really the distances between these edges, right? So the side distance will be the distance between the sides where the side of the container is. This will be the distance between the edges where the PCS is, and so on and so forth. Again, this might not be super intuitive first time. You can also check the diagram to see the pictures, and you'll get everything will be more clear. And well, we also calculate the layout orientation here. This was already done before, but just to review it, you can choose. So we calculate automatically the optimum rotation for the system, but you can always change it here. I will always stick to the rotated one that we calculate, because what we do is basically try to fit as much capacity as possible. We rotate the layout to fit as much capacity as possible in the area. In this case, you don't notice it because we set to a specific capacity, right? But if we were to fill the whole area, you will probably notice it. One thing to notice, right? Well, I will change the number of containers so we can check other configurations. If we choose 4 containers, we go back to the layout option. You see how the options here changed. If I, for example, choose this one and run the simulation, this will take a few seconds, and we'll see the new layout here quickly generated. Yep. So you see how the distribution changes. It's not perfectly rectangular, let's say, the layout, because we always try to install the blocks as close as possible to the MB point, which is defined in here in location inside. You can edit this and basically move the MB point around to try to play where the different blocks are installed. So we always try to keep the MB lines as short as possible, and that's why we install the blocks in this shape here. You can keep playing with the different orientations, different configurations with the distances, right? If I were to choose a different number of containers, for example, 3, for which we don't have a specific distributions defined, you'll see that in the BESS layout tab, you can see you don't have the options for new distributions, but what you do have is still the orientation. So even though the layout like the individual blocks don't have these new options, you can still change this in here. So for example, if I choose mirror and I run the design, you see how we have the 3 containers. You could potentially increase this distance here, because I bet this is not very compliant. You won't be able to open the doors from this container in the middle, so you will have to increase this distance. Let's do so. Put 3 meters between those. You can maybe also set the PCS perpendicular. Yeah, and this looks much better for 3 containers connected to one PCS. So you see how fast we're changing the configurations. Run design super quickly. This generates. You can access all the documentation here. You can download the general layout. This includes the whole PV plant too. You can, if you just want the the battery layout, you can download it also in here. This feature is available also for standalone designs. So if you are creating a standalone design, you can also access all these new distributions. And yeah, before I promised you that we were going to replicate Sungrow's, one of the Sungrow's layouts. So one thing that I like to do is save all the inputs as a template, as I mentioned before, to use it in all my projects. So I have, of course, saved from before a template with this 20 feet standard container, which replicates Sangro layouts. I see some errors here. Let's hope that everything is loaded properly. Yes, it is. You see how this changed to 2 containers. We had 3 before, changed to 2. The distances changed here. I think to replicate one of the Sangros layout, we need to choose. No, parallel, it's okay. Yes, I think. So you see these are the typical distances or dimensions, sorry, for a 20-foot container. Let's check that the alignment is okay. Let's choose mirrored. I think these distances are perfect. They should be, because I saved them from before. Let's choose, yeah, maximum capacity. So we fill the whole area with this. Let's click run design. Maybe this takes a bit more of time because it has to install much more blocks. It should be fine. And while this loads, yeah, I'll show you how, depending on the block, the distribution that you choose, the distances here change. So you only need to define those that really affect the layout that you are generating. So you see how here the distance between containers appears. If I change to this one, no more distance between containers, as containers are no longer next to each other, but they have the PCS in the middle. Same for this, although we don't have more options right now, because also the orientation depends on the distribution that you're selecting here. And sorry, I got confused. This wasn't the layout that I wanted to replicate, although I think, no, this is not Sangro. Well, forgive me, I will take one that I already had prepared. This is an actual Sangro layout with the 2 containers vertically aligned and the PCS in front, and all the blocks looking at each other like this. You see the MV lines in the middle, and all the different blocks installed over the whole area. You see how it's perfectly rotated to fit as much capacity as possible. If the battery area starts being a bit more weird with more edges and so on, the rotation angle may not be perfect, may not look perfect. We always try to install as much capacity as possible. So we try different angles, but if the battery area starts getting very, very complicated, the task for the algorithm starts also being more complex. So maybe you can play around with this rotation angle and try to find the most optimal angle, but in most cases, it will nail the configuration like in this case. I'm feeling generous. I think we have still a couple minutes, so I will change. I will also here show you Tesla's configuration. For example, we have here the 4 containers connected to the same PCS. You see how the dimensions change. This is much longer than before. The PCS is much more smaller. This is because Tesla usually, or not usually, always Tesla's models have the PCSs or the inverters integrated into the containers. If we would like to replicate CATL layouts, it will be more likely something like this, with the containers parallel to the PCS. So yeah, this is it. This is the feature. I think with this, we are now covering most of the layouts that you can generate for PV. Of course, there are more. There will be more coming. Batteries are evolving super quickly. I'll bet that manufacturers will keep generating more weird layouts, but we'll be trying to get up to date always with them. Try to keep adding more and more options. So yeah, hope you like the demo. I will switch back to the other window, and we'll do a Q&A session. Okay, try to answer as much questions as I can. Well, I will stick to the presentation of the layout, and I will go with the questions. So maybe if I still have to show something in the software, I'll have it here at hand. Okay. Janani, it's asking if we do have options of creating layout for both DC and AC coupling with solar. You do have the options to create both layouts for AC and DC coupling, also standalone, but these new options, layout options, are only available for AC and standalone at the moment. But we also do DC. It's super simple to switch from one to another. If we go back to the software, you see here inside BESS type, you can choose AC or DC BESS. Just note that in order to do DC BESS, you need to have central inverters here selected. We don't yet allow string inverters for DC coupled BESS, but we will soon enough, very soon. Actually, we're working on that. So yeah, you can do that. Mm. Jonathan, it's asking if you can get that template. Right now, templates can't be shared, so you will have to go into the software and plug in the data manually and save it for yourself. Right now, there's no way of sharing the templates, but it's just honestly a few clicks to generate your own templates, and you can do that for as many manufacturers and as many things that you want. Shonke, it's asking, does the software provide some kind of road layout tool also for fire department maintenance? How will the racks be replaced? For PV plant, we do generate a road layout. You have multiple options for roads. For batteries, we don't have this feature yet, but we are working on it. It's on the roadmap too. And yeah, well, won't give any dates, but I will say that we are the team is already working on it, and we have it in the roadmap. So you will soon, well, you will see it. Also for fire department maintenance. Oh, well, you're speaking about yeah, the roads right now. Okay, yeah, yeah. You will be able to define the road width, the blocks in between the roads and so on. So you will be able to, yeah, comply with everything you need for the fire department, the different trucks to go in, all the logistics and so on. More things. Also, Jonathan, he's asking, where do we see the time it takes to charge the batteries to full capacity? Can we manipulate the time? So the time that it takes to define or to charge and discharge the system, it's basically managed with the in this option, right? You can see a list of supply cycle duration. So these values are actually the hours that it takes to charge and discharge the containers fully. These values are calculated based on the container capacity. So typical containers that we are seeing nowadays. This is for example, this would be the capacity for the Sangro ST 5015. And then you can hear, oh, sorry, I'm in DC BESS. Let's change back to AC. Okay, now. This will be the capacity, and here I can change the power conversion system and the power. So you can choose from the list of inverters. This database is shared with PV right now. But you can choose the inverter that you want. If you don't find anyone that fits or any inverter that fits you the power that you need, you can always change it. Yeah, it's kind of a workaround this, but you can always change the power in here. So if I were to set this to 2500, I have one inverter per PCS, so you see that the total power of the PCS is 2500, and the container capacity is 5000. So if I have one container, a single container connected to a single PCS, you divide the container capacity by the power of the container, the power of the PCS, and you'll have the minimum hours. If I have one containers, this corresponds to 2 hours. If I set 4 hours, this is 2 containers. If I continue adding containers, I will continue increasing the hours. So this is how we get the hours of supply. Wow, there's a ton of questions. Yeah, Ian is asking about this. Why are the hours shown as 1.01, 2.02? This is because we are dividing the exact values that you input here. So we are dividing exactly 5015 by 2500. This is not exactly 2, but 2.01. So that's what you're saying here, some decimals. In reality, okay, with the rated power of the PCS, this will probably be rounded to 2, and or you can always limit here the power output of the power, or you can increase or limit the power of the PCS, so you get exactly the hours that your manufacturer is basically providing. So if we want to get exactly 2 hours, I'll need to add a bit more of power. And now, oh, well, I don't know how to do math, seems. I thought that this will round up to 2 perfectly. But yeah, let's do it. I have here 5,000. Okay, I know what's happening. This is because probably the rated power of the PCS is a bit lower than what you can see here, because we have this option here to size the inverters and the power conversion systems with a power factor. If I disable this now, we'll probably see, yes, exactly 2 hours. That was it. Okay, more things. Okay, Angela Romero is asking if the different configurations and block distributions that we designed for Tesla, Sangro, etc., were previously agreed with the engineering teams of those manufacturers. In this case, the ones that I showed were based on information that we found online from the datasheets of these manufacturers, from the layout guidelines of these manufacturers, and also from examples of real-world battery plants. So all the distances and the different positioning were taken from there. I assume when actually building, when actually going to build, going for construction, and you'll need a more detailed design, you would probably need to double check if this is actually feasible and if this is actually what the manufacturer is providing. So you will need to double check with these engineering teams. I guess that the more you work with these teams, the more sure you'll be that what you are generating is correct. You're gonna also always ask them to, hey, give me exactly the layout guidelines. What can I do? What can I not? What are the setbacks that you need me to put in here? You fill all that information and you generate the layout, and it will be perfectly reliable. But yes, I suggest to always double check with the engineering teams. More. Okay, I see more questions about roads. Yes, as I mentioned before, we're working on the roads feature for batteries. Everything you save in the template, so everything you configure in the process, in this process of designing the PV plant, the battery plant, being the capacity, the hours, the dimensions, the layout configuration, the roads when we have them, everything that's all those configurations are saved into the template. So if you configure your roads there, it will appear also in the template once you load them into the software. Yanan is asking if this BESS layout is default plugin in PV Design or if it's a separate tool. No, it's included. Everything is included into RatedPower. batteries, standalone, like hybrid designs, I mean, PV and standalone. Mateo, it's asking if we are planning to include more block distributions for more container blocks, if we are planning to add more flexibility to the options, like manually defining how much rows, how many rows, how many columns, and so on. So we're planning into including more options for block distributions. We're planning on adding more. We're planning on adding these options for more number of containers per PCS. And in the future, we will probably also bring to you the option to define this manually and to move around the containers and the PCS manually around the battery area. As we do with PV right now, we have this layout editor option where you can, after generating a design, an automatic design, you can go into this tool and move a lot of elements of the layout around. At some point, we'll bring this also to the battery side. Yes. Nares is asking if cabling and earthing is possible to indicate in layout. Cabling, yes. The medium voltage lines are automatically generated, as you see here. Not yet the low voltage and not the earthing system, but you can see the medium voltage lines. Yes, we generate. Mm. Okay. Aditya, sorry, I don't know how to pronounce this. It's asking if the cable trenches are shown. Yes, we actually show the trenches, but I think they're hidden here. Mm-mm. Yes, they were uh, one on top of the other one, so you couldn't see it. You could just see the medium voltage, but you can also, we also generate the trenches. It's just in this greener tone, you can barely see it, but we generate also the trenches. You can then go to the layout, you can go to the drawing, the CAD file, and check also the voltage, sorry, the trenches in there. You can, of course, download here the bill of quantities file, and you see there all the information about the trenches, the length of the cables needed, and so on. Fan, it's asking if it supports the selection of energy storage devices. Not yet. We don't have equipment added to the software yet. We don't have anything saved, but we are working on adding kind of what we have for PV with the modules and inverters, but for batteries, and to be able to bring to you the different battery container models with the top tier manufacturers, PCS, uh, medium voltage skids, and so on. Michael is asking if is it possible to explain something about financial part of BESS projects. I do have a couple webinars speaking about the financial tool that we have for batteries, because we do calculate here the dispatch and the energy exchange. If you enable it, we do actually You can define some energy prices in here. You can define some financial parameters like the discount rate. You can define your capex. You can define your operational costs, and you can do this financial study. You can check our website. We have I think more than two webinars speaking and going into depth about this. So yeah, feel free to check it out. And we are out of time, so we'll close it here. Thank you everyone for joining. Thank you for attending. Thank you for all the questions. If I left any question without answer, feel free to reach out to our team, and see you on the next one. Thank you very much. Bye bye.